I'm Jan. I work at Foster Partners, and I am co-heading with Joseph the Mars cluster this year. Mars stands for Martian Autonomous Robotic Swarm, and it's a bit of a spin-off of a competition we did at the office for NASA, which looks at how would you autonomously build a habitat on Mars. In this workshop, we're going to get very practical, and we're basically building about 10 swarming robots. We're going to teach them to do several things, and in this specific case, we're going to have them build stuff with sand. The idea is that we actually give them goals rather than give them commands. So it's a bit of a twofold goal in the workshop. First of all, we want to look at this robotic system, this autonomous robotic system, and how does it work, how does it communicate, how can we make it better. And then secondly, we also want to look at how does the behavior actually enhance what the robots are doing. The goal is a bit to take 1 and 1 and get 3. We designed the robot over the past 2-3 months that we know that works, but the participants are very free to also expand it and change it as they want. It's a bit of a tinker workshop. So yeah, we have a very nice manual set out, and by the end of the day we'll have hopefully 9 robots running. It could be a long night, we'll see. But I mean, it should be possible. We've got a lot of bright minds in our cluster, so we're really excited about it.
My name is Richard Marc. I'm from the Specialist Modelling Group at Foster Partners. My role is, I suppose, a software geek here in the cluster. What I'm doing is the tracking software for the Connect, and also telling the robots where they need to move and go to. Each robot uses the Connect to understand where it is within the system in a short sort of its own vision area. So the Connect is focused down on the sandpit with the robots, and we can read the height of things over about a 4x4 metre grid. So far it's been going to plan. We've got, we've spent quite a lot of time building the robots, which is good. We now have a fleet of 7 robots that may one day take over the world, we shall see. And we're just putting in that final piece of the communication puzzle so that the robots can talk and understand and know what's going on. And once we've got that in place, hopefully this evening we can test it and see some critters moving around.
Okay, my name is Xiaoming. I'm from Foster Partners. Actually, my daily job is as a daylighting and lighting designer. But here in this cluster, I'm working to build self-swarming robots, and how that could lead to the final structure we want to build. Yesterday, I quickly talked to them and about how the system in software parts works, and a lot of them actually start to building their own version of the software, and some is working quite well. I'm quite surprised the participant has very broad backgrounds. Like some has like a theoretical physicists, and some of course architects, engineers, and all have their interests. Some are more into the hardware, some into the software, some know the swarm theory very well. So actually everyone is like a great piece of the team.
Hi, I'm Joseph from Foster Partners, the Specialist Modelling Group. So the whole point of making a project on Mars is to 3D print a habitat without bringing material from Earth. I guess if I say 3D printing a building, what you imagine is a big robot that's doing, like, it's like a hyper robot that can do whatever you tell it. And we're saying, well, it might be a bit overcomplicated. Why don't we try to distribute all the functions we need to do? So it's a distributed system that is composed of multiple little simple devices that together create an object. And this idea is inspired by natural systems.